This lesson is for Mrs. Cucci's College Now PreCalculus class. We are on lesson 5.4, radians, arc length, and angular speed. So if you want to go ahead and get that file open, we'll get started. Okay, so what we're going to talk about now is arc length and central angles. Radian measure can be determined using a circle other than a unit circle. Along with that is something called a central angle. So from geometry, we know that the arcs that the angle subtends have their lengths in the same ratio as the radii of the circle. The radii of the circle are r and 1. So that's going to correspond to the arc lengths of s and s sub 1. So we have this formula that we're going to use, all right, S equals r theta. Now you have seen this formula before. We used it last year in trig, so it's not any different from that. We're going to just do some review on that. All right, so radian measure, if we're talking in terms of radian measure for this formula, the theta in this formula does have to be in terms, or the angle measure in this formula does have to be in terms of radians. So that's very important that you remember that. Okay, so the radian measure theta of rotation is the ratio of the distance s traveled, here's my s, or my arc length, by a point at a radius of r, here's the radius, okay, from the center of the rotation to the length of the radius, theta being the angle that's created in that rotation. So we're going to find the measure of rotation in radians when a point 2 meters from the center of a rotation travels 4 meters. So what we want to do is we want to go through and draw a picture for this, okay? So again, you have a point 2 meters and it travels a distance of 4. Okay? What we want we want that angle that it creates. Okay? All right, so when you have something like this and you have the arc, the angle, and the radius, we're going to go straight to our S equals r theta. Remember, S is my arc length, r is my radius, and theta is my angle in radians. So when I solve this out, if I have everything except for the theta, when I solve it out, it's going to give me that angle in terms of radians. Okay. So now when I go through and I divide this, and I should be using my units, I apologize. When I go through and I divide this, notice my units cancel, and I get 2. And this is going to be 2 radians. Okay, so that's all there is to it. All right, so let's try the next one. Find the length of an arc of a circle of radius 5 centimeters associated with an angle of pi over 3 radians. Okay, so now this time they're telling us that the radius is 5 and the angle of rotation is pi over 3 radians. So we're going to sketch out our little circle here, or our piece, I guess, our arc. They're telling us our rotation is pi over 3 radians, and our radius is 5 centimeters. We're looking for the arc length. Okay, so again, S equals r theta. We don't know S. We know that our radius is 5 centimeters, and we know that our rotation is pi over 3 radians. So when I multiply that, I get 5 pi over 3. And since this is a distance, I do want to evaluate it or put it into my calculator to see what that decimal is. And when I do that, I get a length of approximately 5.24 centimeters. Okay? All right, so linear speed and angular speed is what we're going to talk about next. Linear speed is defined to be distance traveled per unit of time. If we use v for linear speed, s for distance, and t for time, we wind up with this formula, v equals s divided by t. Okay? Or linear speed equals distance divided by time. Okay, so similarly, angular speed is defined to be an amount of a rotation per unit of time. For example, we might talk about angular speed of a bicycle wheel as 150 revolutions per minute, or the angular speed of the Earth as 2 pi radians per day, 360 degrees per day. Thus, a rotation theta and a time t, angular speed can also be defined by theta divided by time. Okay, angular speed is the rotation divided by the time. Okay, so linear speed in terms of angular speed. Linear speed, or v, of a point, a distance r from the center of rotation, that formula is going to be v equals r times angular speed. Okay, so you've got v, which is linear speed, r is distance, and that little w looking thing is your angular speed. Okay, so linear speed equals the distance of a point from the center of rotation times the angular speed. So you're going to want to write these down, put them on a note card, make sure you're describing on there the difference between them and what they mean, each variable means. Okay, that's up to you to do. All right, so for this formula, the units of distance for v and r must be the same. Okay, this angular speed must be in radians per unit of time. And the units of time for these two variables must be the same. Okay, so you're going to have to match up those units of time here. All right, so let's take a look at an example. Linear speed of an Earth satellite. An Earth satellite in circular orbit, 1,200 kilometers high, or kilometers high, makes, kilometers? Kilometers, makes one complete revolution every 90 minutes. What is its linear speed? Use 6,400 kilometers for the length of the radius of the Earth. Okay, so to use the formula we're going to use is going to be our v equals r times w. Okay, so we need to know what these two variables are. All right. So, in order to get the radius, we kind of have to do a little work to get there, okay? We're talking about an Earth satellite in circular orbit. We know that what the radius of the Earth is. It told us it was 6,400, right? But on top of that, we also need to know how far off of that Earth's radius my satellite is, and that was another 1,200. So I do have to put those together. If we think about this, here's my Earth, here's the radius, 6,400, right? But my satellite is out here. So I do need this piece as well to be added to it, so I know the total distance here, okay? So that's going to give me my value of r. All right, so for W, we need to determine that using the formula we were given, theta divided by t. Okay, so we know that the Earth makes one full rotation to be 2 pi. And according to our problem, that's happening every 90 minutes. So that's going to be pi over 45 minutes. So there's our W. So now we can go back up and use this. Now that we know what R is, what W is, we can use it. So V equals 7,600 kilometers times pi over 45 minutes. And notice I'm using my units in there. Okay, we should have those in there. So that's going to give me 7,600 pi over 45, and that's kilometers over minutes. And that is going to reduce down to approximately 531 kilometers per minute. Okay, so the linear speed of the satellite is approximately 531 kilometers per minute. And notice I'm writing a statement at the end. Okay, guys, you should be doing that as well. Get used to doing that. You're going to be doing that in college constantly. Okay. So sometimes you do have to go find missing pieces. That's okay. It might take a few minutes, but it's not difficult work. You just have to really think about the problem, think about what they're asking, think about the setup. Draw a picture. Okay, pictures are going to be important for you guys. All right. Let's take a look at another. Angular speed of a capstan. An anchor is hoisted at a rate of 2 feet per second as the chain is wound around a capstan with a 1.8 yard diameter. What is the angular speed of the capstan? Okay, so most of you are probably thinking, I don't know what the heck you're talking about. Well, a capstan is on a boat, so I'm going to draw myself the world's most ridiculous looking boat. I'm going to apologize in advance. Here's my boat. Okay, a capstan is on the front of a big boat, and what this thing does is it turns, so it turns around and around, and it pulls the anchor up. Okay, so is this an anchor? What's an anchor look like? I think that's a pretty darn good anchor. Okay, so what this thing is going to do is it's going to pull and it's going to rotate, and it's going to pull up the chain and the anchor on the bottom. Okay, so that's what it's doing. So what we're going to do is we're going to use this formula again. Although we're looking for what the angular speed is. So the variable we're actually looking for is this one here. Okay, so we can use this in the form W equals V divided by R. Okay, so first things first, let's figure out the radius. It told us that the diameter was 1.8 yards. The diameter is twice the radius. So what we want to do is we want to take that diameter and we want to divide it in half. Okay. So when we do that, we get, let's see here. We get kind of an issue. We don't want yards. What we want is feet, because our rate at which we're being hoisted was 2 feet per second. Okay, we want feet. So now I guess you need to know how many feet are in a yard, and I'm guessing many of you do not. So let's talk about that real quick. So in order to determine what this is in feet, what we're going to do is we're going to multiply it by 3 feet over 1 yard. Okay, because there's 3 feet in a yard. So when we do that, we multiply this through and do out the division. 1.8 times 3 divided by 2. We're going to get about 2.7 feet. Again, because this is in feet per second, I need feet, not yards. Okay, so there is my radius. So then my angular speed is going to be in radians per second. So I've got W equals 2 feet per second which was given to us. Okay. Divided by 2.7 feet. And I want you to pay, why does this keep doing this? Pay close attention to your units here. Okay. These feet cancel out. All right. So we wind up with 2 divided by 2.7, which is approximately 0.741 seconds is what we're left with. Okay. So thus, the angular speed is approximately, I'm going to shorthand this, sorry guys, 0.741 radians, because remember, its angular speed is a rotation, radians per second. Okay? So it is radians. We're talking in terms of radians here. All right, so the formula theta equals angular speed times t, and v equals r times w. These can all be used in combination to find distances and angles in various situations involving rotation. Okay, so these are just different kinds of formulas that we're going to be using to help us find solutions to rotation problems. Okay, angle of revolution. 2010 Dodge Ram Crew Cab 4x4 is traveling at a speed of 70 miles per hour. Its tires have an outside diameter of 29.86 inches. Find the angle through which a tire turns in 10 seconds. Now, a couple things here I want you to think about. Notice we have seconds. Let's talk in terms of time, right? We have seconds and we have hours. All right. 70 miles per hour. We have miles, we have inches. So we're going to have some issue with our units, so we have to pay close attention to that. All right, so remember, we have this formula here, or we could use this. Okay, same thing. We can find theta if we know W and T. To find W, we have to use this. So we have to use that to find W, okay? The linear speed, V, of a point on the outside tire is the speed of the Dodge Ram. So that's 70 miles per hour. For convenience, we need to convert that 70 miles per hour to feet per second, because that's really what we're going to be talking in terms of, okay? So I know that V is 70 miles an hour. Okay, I want to convert that, so we're going to multiply it by 1 hour, 60 minutes, right? And to break that down even further, 1 minute is 60 seconds. Okay, and we know that that is, when we're talking about miles, 5,280 feet in 1 mile. So you have to kind of you have to break it down step by step. An hour to a minute to a second. Hour, minute, second is what you're going to be left off with. And then mile is going to bring us to feet. All right. So when we do this multiplication, we go straight across. And we wind up with 102.667 feet per second. Stella, stop. Sorry. Okay, so you just multiply straight across here. And what winds up happening, how we get that unit conversion, is minutes is going to cancel, hours is going to cancel. Okay, see how we're getting this? Miles is going to cancel, and I'm left with feet over seconds, which is the units that we want to convert to so that we can use these formulas up here. Okay. So the radius of the tire is half the diameter, so we have to kind of adjust for that as well. Okay. Which we know the diameter was 29.86. Divide that out by 2. And that's going to give us 14.93 inches. Come on. Okay. But since we're not talking in terms of inches, our unit is feet, we need to adjust that. We know that we have 1 foot in 12 inches. Now, if you're not sure how to set this up, you should know this basic conversion. Notice my inches here, now my inches are on the bottom. We do that so that that unit cancels. That's the goal. Okay? So what that does is it gives us 14.93 divided by 12. And that's going to wind up being feet, which is going to be approximately 1.24 feet. Okay, so now what we have is we have R and we have V. What we can do is then find W using this formula here. Okay, so we know that V equals R times W. I have R and V. V is 102.667 feet per second. And that's going to equal 1.24 feet. And that's what I'm solving for. So I'm going to divide. Okay. And when I divide that out, I get W to be 82.80 seconds over seconds. Okay. So if I'm talking in terms of seconds, and I know I'm way over in time, guys, I apologize. If I'm talking in terms of seconds, we want to know how many rotations in 10 seconds. What we can do is just multiply this by 10, and we get 828. All right, guys, that's it. Thanks for holding on and listening, and come prepared with any questions.